rectangular coordinates are those that lie on the square grid of the Cartesian plane, and so they should be quite familiar to you. Now there is something called the polar coordinate system, which is based on a circular graph rather than the square grid of the Cartesian system. So points in the polar coordinate system are in the format of r theta. And so r is the distance from the origin, and the origin is the center. And so another way to describe this would be as the radius. And so that's easy to remember because radius starts with r. And then theta has a somewhat long definition. It can be defined as the smallest positive angle. So I'm abbreviating here with positive and angle. The smallest positive angle moving in a counterclockwise direction made with the positive horizontal axis. So that's a lot to digest, so I'll say it again. Theta is the smallest positive angle moving counterclockwise around the circle made with the positive horizontal axis. Now, if we have the rectangular format and the polar format, there has to be a way to translate between the two. So if we're trying to convert from the rectangular format to the polar format, there's two equations we have to use. So the first is to find r, and we do that by taking the square root of x squared plus y squared. So that's really simple. And so in that case, you're going to use, if x is positive, you're going to use the positive square root value for r. And then if x is negative, you're going to use the negative square root value for r. So that's pretty easy because if x is positive, you're using the positive square root value. If x is negative, you're using the negative square root value. So the second equation we're going to have to do is to find theta. And so theta is equal to the arctan of y divided by x. So arctan is short for arctangent, and arctangent is just the inverse of tangent. So that's how you find theta. However, there is a catch. X cannot equal 0. So that sign right there means not equal to. Now, this equation right here always works as long as x doesn't equal 0. But sometimes x will equal 0. So in that case, there's three different scenarios that can be played out. If both x and y equal 0, then theta equals 0. So that's pretty easy to remember. If we're dealing with 0 and 0, then we're going to get 0. Now, if x equals 0 and y is greater than 0, meaning it's larger than, then theta is going to equal pi divided by 2. And then finally, if x equals 0 and y is less than 0, meaning it's negative, then theta equals 3 pi divided by 2. Now, if we're able to convert from the rectangular format to the polar format, we have to be able to go also in the opposite direction. So if we're trying to convert from the polar to the rectangular format, it's quite simple. But again, we have to do two equations. Why? Because we're looking for two variables. So we have to first solve for the x variable. Actually, it doesn't matter. You can solve for x or y first. But say we start with x, then we're looking for r cosine theta. And then for y, it's a similar equation. We're looking for r sine theta. So if you're looking for x, you're dealing with cosine. If you're looking for y, you're dealing with sine. So just remember that when converting between the polar and rectangular formats, you're always going to have to do two equations because you're solving for two variables.